The other way that we can do, we do integral for both fx and fy. Okay. We know that fx, no, derivative of f by dx is equal to m. This is what we know. I put fx because I know that the function which is appeared here is going to be anything related to variable n. So I just put it by intention. And then to find this fx, I do it this way. The reason why I change from the curve to dx because I am going to integral compared with x. Okay? And then after I do the integral like this, I would get fx equal to md, integral m dx like this. And then I put m in there. Okay, and then I just integral each term using the property of integral that they have the property of distribution. Okay, so I would get each term like this. Whenever we integral with x, we look at y as a constant. So I can take y out of the integral. This one also, we look at x. We can take y out of the integral sign. Okay. Integral dx equal to x. Okay. Integral exponential of x dx equal to exponential of x. Okay. But this one you got to do by part. Okay. The way that you do by part, you got to define what is u and what is dv. Okay. So I take u as the x and dv as the exponential of x dx. From whatever I picked, I would get du equal to dx and v is equal to exponential of x. Okay, and then I just use this by part technique. Okay, I would get uv minus integral v du. My u and v is x times exponential of x minus integral v du. V is exponential of x and du is equal to dx. And at the end, I would get x times exponential of x minus exponential of x. And then I just plug it in there. Why put it outside? Because y is a constant. That is. So I would get my fx is equal to x plus x times exponential of x times y. I do it again with what? With y. dfy by dy equal to n. I just did exactly the same. Like put dy to the n and then integral for both sides, I would get fy is equal to integral n dy. And then I know that my n is equal to x times exponential of x plus 2. Now, whenever you integral with y, look at x is a constant. Okay? So, integral constant equal to constant times y. So, I would get x times exponential of x times y plus 2y. Okay? And then, because actually this fx and fy has got to be the same function. So I just make them union to each other. When you do union, you see, this is fx and this is fy. You would get any term that appear at the fx and fy, you write it down one time, which is x times exponential of x times y. Okay, so But the rest, you just can write it down. Now I got my fxy. And then the answer is just that fxy equal to c, where c is a constant. But we already know that our fxy is equal to x times exponential of x times y plus x plus 2y equal to c. That will be the final answer. As you can see from both techniques, you would end up with the same answer. So you can pick up either one. Any questions? That is the way to find the answer for exact equation. Another example. When you look at the equation like this, now it's already in the form of mdx plus ndy equal to 0. So it's okay. But the thing is that you got to check whether this equation is an exact equation or not. Okay. So we got to check it. Differential of m by y is supposed to be equal to differential of n to the x. Now our m is equal to n is equal to x to the power 3 plus 2y. Right? M is equal to times 3 times x to the power 2 times y minus 6x. And n is equal to x to the power 3 plus 2y. You do derivative of m compared to y. Whenever you do it this way, you got to look at x is a constant. So the first term, when you do derivative, you would get 3 times x to the power 2. And for the second term, you would get 0, right? Because it's a constant. You do derivative of constant, you would get 0. Now, if you take a look at n is equal to x to the power 3 plus 2y. You do derivative of n with x. So the first term you would get 3 times x to the power 2. But the second term, because you do derivative with x, you look at y as a constant. So the second term you would get 0. Okay? Now, I would find fxy. M is equal to 3x squared y minus 6x. When you do the integral with respect to x, you look at y as a constant. Okay, so you would get is we don't know what is our gy. So we got to put it that way. To say that, okay, we know that if you dip this term, this f by x, this term is 0. So when you integral it back, it's got to be shown. But we don't know what is it. Okay? Now, integral 3x to the power 2 dx equal to x to the power 3, right? Then you would get x to the power 3 times y. Integral x dx. I think it's correct. And now this term, integral x dx is x squared divided by 2. 2 divided by 6 is equal to negative 3 times x squared plus dy. Now, if we can find dy, that would be fxy. But how do we find dy? We can find dy from this definition. And our n is equal to x to the power 3 plus 2y. Right? What we got to do is we dip this f to y. Okay? We know that our f is equal to x to the power 3 times y minus 3 x squared plus dy. That is what we find from m. That is what fxy that we find from m. But we don't know gy yet. We try to find dy from m. And we know this definition. But since we already got our f there as a function like this, so we do derivative of this one compared to y. Whenever you dip it, you do derivative of x by y, you look at x as a constant. What you get? X to the power 3, right? You dip this one by y. The second term you get what? 0. And then plus gy. Derivative of g to y. Then I plug this one up back here. I will get and then you see now you have x to the power 3 and x to the power 3 there. They all cancel out. Right? You move this one to there. You would get minus x to the power 3. X to the power 3 minus x to the power 3 equal to 0. So now you would get equal to 2y. Now, like I said, we're almost about to be done to find fxy. Only if we know gy. And this is the equation that makes us find gy. Right? So we know that dgy is equal to 2y dy. You do integral for both sides, you would get dy is equal to what? Y squared. So that means you would get fxy equal to x to the power 3 times y minus 3x squared plus y squared equal to c. That is the answer. You don't want to do this way, you can do either way, the other way. The other way that we do integral for both um, integrals compare with x and y. Right? And then it said that we do integral for both sides, we would get fx equal to, when you do integral with x, you look at y as a constant, you would get so this one you get y times x to the power 3, and this one you get 3x squared. And then you do the other one. When you integral by dy, you look at x as a constant, so that's why you can take x out from the integral sign. Then you would get x to the power 3 times y plus y squared. Now, you do fx union fy, which is equal to fxy. You know your fx is x to the power 3 times y minus 3x squared, and your fy is equal to x to the power 3 times y plus y squared. So when you do union, you would get x to the power 3y plus y squared minus 3x squared. And the answer is equal to C. So the final answer you can write down this way. So you do both ways, either way you would end up with the same answer.